Hi guys, welcome back to another video of the Raspberry Pi tutorial using the Freenove Ultimate Starter Kit. My previous video had a pretty bad audio quality, so I'm kind of redoing the second video and combining the two projects all together in chapter 2. So for this video, I'm working on chapter 2, which is called Buttons and LED. The first project is called Push Button Switch and LED, and the second project is called Mini Table Lamp. So if you have already watched my first video, you can skip to the second part where I'm doing the Mini Table Lamp project. So throughout the tutorial, you'll notice that I'm more or less following the tutorial provided by the Freenove Ultimate Starter Kit. So you can reference to them directly if you want a more clearer picture of how the wiring diagram is being wired and how the Python code is being written. So in this first project, we'll be using a push button to activate LED light. So the component needed in this project are, let me just open up the camera for the Raspberry Pi. So okay, the component needed in this project are a bunch of jumper wires, a 220 ohm resistor, a red LED, a 10K resistor, and a push button. So the new components introduced in this chapter are the 10K resistor and the push button switch. This is basically how the push button switch works and how it's used in the project. So okay, if you can see here, this is basically the push button. And if you look at the push button closely, you'll notice that there are two sides that have the two pins protruding out. This is one side of it, and this is the other two sides. And you also have two sides which are flat over here. So okay, back to our diagram. So the two sides that have the two pins protruding are 1 and 2, and the other two sides are 3 and 4. So basically the flat side, the two flat sides, 1 and 3, 2 and 4, is internally connected to each other. So when you press the push button, 1 will be connected to 2, 3 will be connected to 4. So basically this is how the push button switch works. So we also need an input to read the status of the push button, else we won't know what state the push button is in. So in this case, we are connecting a wire back from point 3 over here, all the way back to one of the channel in our GPIO board. So in this case is GPIO 18 channel 12. So in the perfect world scenario, this should work right. But then in the spaces around us, there exists a lot of interference, either from our computer, laptops, router, even the Raspberry Pi itself. So there's a lot of like electric field interference all around us. We can't really see it, right? So the switch doesn't really stays up all the time. So because of all these interference, it kind of toggle up and down, which we really can't see. So this is where the second component, the new component introduced, comes into the picture, which is the 10K ohm resistor. So this is where the 10K ohm resistor will be placed right before the switch. Let me get this resistor into the circuit. Okay, there it is. And a 10K ohm. Alright, so what this 10K ohm resistor does is it kind of prevents the interference causing the push button switch to toggle up and down, which is why it's called push up resistor. So there are quite a lot of good videos out there explaining how the pull up or pull down resistor works. If you're interested to know more about them, just do a quick search on YouTube and you'll find them. So with the component introduced, let's start with the wiring of the circuitry, which I'll start off with the push button circuit first. Then we will proceed to the part where we will wire the LED. So what we'll first do is to connect the 3.3 volt over here to one of our point here. This looks like the wire is a bit too long. Let's use something shorter. The 3.3 volt over here. to 0.25 and introduce the 10k ohm resistor over here just before our push button switch, which will push it here, make it slightly nicer. And we'll need to ground this back to our circuit, which will be using the ground over here, and that will connect. That should be completed for the push button, and now we'll need the output over here and to GPIO 18. Alright, and we are done with the push button circuitry. The next will be for the LED light. So for the LED light, we are using GPIO 17 over here. Can't really see. Yeah, over here. And let's go all the way down here. And we'll add our 220 ohm resistor. And remember, the long side will go in first, and the short one will go back to the ground, which we already have a ground, so we will share the same ground over here. Alright, and I think we are done. Okay, so now let's start with the Python programming, and let me power up the Raspberry Pi. And we have our Raspberry Pi connected. We shall now open the program, the Tony Python IDE, and we'll start with the programming. Now let's start with the programming. As always, we'll need to import the library to use the function of the GPIO board. To do that, we'll import the Raspberry Pi .gpio and name it as GPIO. So, and next we will need to define the channel for the LED and the buttons. So for the LED pin, which will be channel 11, and for the button pin, we will be using channel 12. So the next part will be where we set up the boards and the pin. So for that, we will use the function setup, and first thing to do is to set up the board numbering, which is to use the GPIO.setMode and set the mode to GPIO.board. The next is to define our LED pin. So the LED pin channel will be 11, and it should be an output where we will be sending our signal out to control the LED light to turn on and turn off. And for the next portion, we will be setting up the button pin to detect the GPIO input. So basically, if you follow the tutorial provided in the Freenove Ultimate Starter Kit, you'll see that over here they add in this additional line of code, which is called pull up down is equals to GPIO.pud_up. So basically what this does is exactly like what we have wired here. It's a pull-up resistor mode that the GPIO has internally has this pull-up resistor that's installed in. That's kind of like built-in them. So we actually do not need this. But if you want to follow the code, you can put it in, it doesn't matter. So in the event that you do not have a 10K resistor, you can just put in this pull up down equals to GPIO.PUD_up, and it will act as a pull up resistor. But in our case, we actually do not need this. So we'll just not use it. Else it's just like double work, right? And next is where our main part of the program is, which we'll call it, as usual, loop. So basically what loops does is, while it's true, means that it keeps on looping forever, unless you give it an input to stop the program, is it will check for GPIO.input, the button pin, whether it is being pressed or not. So to do that, we'll ask it to check if the GPIO is low or high. So when the button is pressed, it will be low. And what does it do when it becomes low? It should send an output to the LED pin and tells it to turn on, which is high in this case. And after doing it, you want to print out the statement saying, alright, the LED is turned on. And we're done with the checking of the button press. So now it needs to do something if the button is not pressed. So what does it do? If it's not being pressed, it should send a command to tell our LED pin to turn off. So to do that, we'll say GPIO is .low, and also print a statement and say that the LED is turned off. I wonder why there's all these arrows. It's probably to indicate that the LED light is turned on and the LED light is turned off in the other direction. So as usual, we'll need this function called destroy that will clean up the GPIO board once you exit the program. So this is the code, and the main part for the program, not really the main part, the entrance for the program is this underscore name is equals to underscore main. So basically what this does is in the command line, when you key in the Python name, it will start to run the program. Basically that's it. So when the program is starting, you also want to tell whoever that is running the program that the program is starting. And once it starts, you will want to set up the LED, or set up the board, which is the setup function code, and start to run your main program, which is the loop. And the next thing you do is, in the event you want to exit the program, so we'll put this keyboard interrupt. So by putting in this code, it means that if you press Ctrl and C, you end the program. And before you end the program, you want to clear the GPIO board, which is to use this function destroy. And we are done. So let's save the program. Save it under here, buttons and LED. Alright, replace. Okay, now we open our command line. And navigate to our folder where we save our program and run the program call. And definitely use Python to run the program, button and led.py. Oh, What did I do? Missed out something in the GPU. Oops. What was the error again? Ah, I see. I missed out the pin. Save it again. Run the code again. Alright, what's happening? So apparently I have the wiring done incorrectly. It should be here. And let's run the program again. It's not correct. Something is wrong. You guys can't see, but I actually missed the pin. It should be here, and this should be back here. Alright, let's do again. And we should be good to go. Alright, that's a bit of troubleshooting. And some problem in the coding and some problem with the wiring. Basically it happens. And that's the fun part of doing with playing around with your own electronic, right? So to exit the program, just Ctrl C and we're done. Alright, and we're done with the first project. So the second part of the project, which is called table lamp. In the previous project where the LED only turns on when you press the button, and when it only turns off when you release the button. So it doesn't stay there like a table lamp. So for a table lamp, when you push the button one time, it will turn on and it will stay on. And when you push the button again, it will turn off and it will stay off. So in this project, we'll be changing some portion of the code to allow the program to read and remember the last action executed by the user, which is us. So by doing this, you only need to press the push button once. The LED should stay on, and only when you press on the push button again, the LED will turn off. So the circuitry is exactly the same, so we'll go straight into the coding portion. So now we'll open the new Python program, and the first part of the code is almost the same. We'll import in the GPIO library. GPIO, and we will need to define the variables. So it's the same. So it's the same. LED pin is 11, channel 11. The button pin is channel 12, and there's a new variable that we will define here, which is LED state. We'll give it a state false initially, and we'll explain what it does later part. So the first portion, we will be defining the setup as usual. So what the setup does is to set the mode for the GPIO board. So the numbering will be GPIO.board, and we will set up the individual channel. LED pin is a GPIO.output, and the button pin will be a GPIO input. It's the same, exactly the same. So now the new portion, the new function here is called channel button event. So there are a few new variable that's or new keywords that introduced here. So we'll explain this channel here later. So but the first thing here is you notice that we have a keyword here called global, and there is this variable that we have defined earlier, LED state again. So what this does is any variable that is defined outside of any function, you'll be only able to read it, but you wouldn't be able to write to it. So in this case, because this particular function will be for the LED to turn on and off, so basically we'll need to write, we'll need to so-called change the state of the LED within this function. So to do that, we'll need to add in this keyword global and so-called tie it to this LED state variable. So the next statement here is print button event GPIO %d %channel. We'll explain this portion later because we'll need to tag along it with the next function. So we'll just carry on here to write the code. LED state is not LED state. So what this does is, every time this function is being called, the LED state will change. So what this does is, every time maybe you press the button, and the LED state will be initially false, it will become true. So every time this function is being called, the LED state will change its own state. So how does this help the program? Is where this portion of the code comes in. If the LED state is on, it will say print LED is turned on. Else, if the LED state is not on, what will we do? We will just print the LED is now turned off. And after doing all this, you need to change the state of the LED pin. So this portion of the code basically runs in, every time when the push button is pushed, so this line of code is being run. So what it does is, it will first change the state of the LED from false, which is the first state, and change it to true. So if the LED state is true, it will say yes, the LED is now currently turned on. And it will send an output to the LED pin to turn on the LED. So the next time when you press the switch again, this function will be invoked again, and since it's true previously, it will come in and change the state of the LED to false, and now the LED state is false, it will print the statement, the LED is turned off. And the same thing, it will send an output to the LED pin, and since the LED state is off, it will turn the LED to off. So basically this is what the function does, and the next portion is where we will define the main loop. So this is also a new function statement introduced in this chapter, which is called gpl.add_event detect button pin. Notice there's quite a lot of variables that's introduced here in this function. Let me just finish the coding and explain what it does. So basically this is a GPIO library function. So what this does is, you will detect an action done on a specific channel. So for this case, button pin, which is our button status, you will detect change of status in this particular button pin. So over here you see the second parameters is gpl.falling. So there's basically there are two parameters here. One is gpl.rising and one is gpl.falling. So in our case, if you remember, every time when you press the push button, it will send a 0 command, which is falling. So which means that it's actually detecting for button pin every time when you push the button and 0 is detected. The third parameter, which is callback button event, is to call the button event over here to start activating. And the last parameter you see here is called bounce time. So bounce time basically is if it's to ignore, if bounce time, it's in milliseconds. So over here you see the parameters is 300 milliseconds. So if you press the push button very fast within a short period of time, it would ignore, basically it would ignore this action for 0.3 seconds. So let's go back to this parameters here, channel. So what this does is every time when you call back the third parameters here, callback button event, it pushes through the channel number that is detecting. So this is where this comes in, and every time when you activate the push button, the channel 12 will be pushed to this particular function, and this is where the second statement kind of show that actually there is a variable coming into this function, and what is the variable, the number of this variable. So basically we'll print button event GPIO %D. % is a placeholder and D is basically a numeric. So basically it takes channel, the numeric, and print out the channel number here. So we'll actually see it runs in the program later. Let's finish the code here. So as usual, this will be needed. The destroy function to clear up the GPIO. And the last portion, which is the name and the main function. So every time the program is called, it will run setup first and try loop and accept keyboard interrupt. It will destroy. Right. So we are done. Let's save the file as mini table lamb, save, and see if it works. Right, we're gonna run the program here. The program is starting, and we push the button one time. And if you see here, it will print event GPIO.12, which is the channel number of our push button. So if you press the button again, the LED will turn off, and it works. Great. And we are done with chapter 2 of the project, and I hope you guys liked it, and if you can, subscribe and like the channel.